storage classes. A storage class defines the scope or visibility and lifetime of variables and/or functions within a C program. There are following storage classes which can be used in a C program: auto, extern, static, register. Automatic variables are declared inside a function in which they are to be utilized. Are declared using a keyword auto. Example, auto int number. Are created when the function is called and destroyed automatically when the function is exited. These variables are therefore private or local to the function in which they are declared. Variables declared inside a function without storage class specification is by default an automatic variable. Auto is the default storage class for all local variables. int, count, semicolon, auto int month, semicolon. The example above defines two variables with the same storage class. Auto can only be used within functions, that is, local variables. Automatic variables for example program. Output. About auto variables. Any variable local to main will normally live throughout the whole program, although it is active only in main. During recursion, the nested variables are unique auto variables. Automatic variables can also be defined within blocks. In that case, they are meaningful only inside the blocks where they are declared. If automatic variables are not initialized, will contain garbage. The features of automatic variables are storage memory, default initial value, an unpredictable value which is often a garbage value. Scope, local to the block in which the variable is defined. Life, till the control remains within the block variable is defined. External variables. These variables are declared outside any function. These variables are active and alive throughout the entire program. Also known as global variables, and default value is 0. Unlike local variables, they can be accessed by any function in the program. In case local variable and global variable have the same name, the local variable will have precedence over the global one. Sometimes the keyword extern is used to declare these variables. Extern is used to give a reference of a global variable that is visible to all the program files. It is visible only from the point of declaration to the end of the program. The extern variable cannot be initialized, as all it does is point the variable name at a storage location that has been previously defined. When a programmer has multiple files and he defines a global variable or function which will be used in other files also, then extern will be used in another file to give reference of defined variable or function. Extern is used to declare a global variable or a function in another file. Syntax for external declaration. As far as main is concerned, y is not defined, so compiler will issue an error message. There are two ways out at this point. Define y before main. Declare y with the storage class extern in main before using it. External declaration examples. Note that extern declaration does not allocate storage space for variables. External variable examples. External variable never disappear because exist throughout the execution life of the program. They can be used to transmit value across functions. They may be hidden if the identifier is redefined. All functions have external storage class. This means that the keyword extern can be used in function definitions and in function prototypes. For example, extern doubles in double in a function prototype for the sign open close bracket function. Its function definition we can write an extern within a function provides the type of information just to that one function. The extern declaration does not allocate storage space for variables. The features of external storage class variable are as follows: storage memory, default initial value 0, scope global, life as long as the program execution does not end. External variable for example program. Here, extern keyword is being used to declare count in another file. Now compile these two files. This file produce write program which can be executed to produce result. Count in main C will have a value of 5. If main.c changes, the value of count -write.c will see the new value. When the function references the variable count, it will be referencing only its local variable, not the global one. Global variable example. Once a variable has been declared global, any function can use it and change its value. The subsequent functions can then reference only that new value. Output. Static variables. The value of static variable persists until the end of the program. It is declared using the keyword static like static int x semicolon, static float y semicolon. It may be of external or internal type depending on the place of the declaration. Static variables are initialized only once when the program is compiled. Static is the default storage class for global variables. The two variables count and road both have a static storage class. Static variable can be seen within all functions in this source file. At link time, the static variables defined here will not be seen by the object modules that are brought in. Static can also be defined within a function. If this is done, the variable is initialized at runtime but is not reinitialized when the function is called. Inside a function, static variable retains its value during various calls. Static variables for example program. Here, keyword void means function does not return anything and it does not take any parameter. This will produce the following result. Static function. Static declaration can also be used to control the scope of a function. If one wants a particular function to be accessible only to the functions in the file in which it is defined and not to any function in other files, declare the function to be static. Internal static variable are those which are declared inside a function. Scope of internal static variables extends up to the end of the program in which they are defined. Internal static variables are almost same as auto variable except they remain in existence, alive, throughout the remainder of the program. Internal static variables can be used to retain values between function calls. Examples: internal static. Internal static variable can be used to count the number of calls made to function. Example: output. External static variables. An external static variable is declared outside of all functions and is available to all the functions in the program. An external static variable seems similar simple external variable, but their difference in that static external variable is available only when the file where it is defined while simple external variable can be accessed by other files. Register variable. These variables are stored in one of the machine's register instead of RAM and are declared using register keyword. Example, register in count. This means that the variable has a maximum size equal to the register size, usually one word, and cannot have the unary AND operator applied to it, as it does not have a memory location. Register int miles semicolon. Since register access are much faster than a memory access, keeping frequently accessed variables in the register lead to faster execution of program. Register should only be used for variables that require quick access, such as counters. It should also be noted that defining register does not mean that the variable will be stored in a register. It means that it might be stored in a register depending on hardware and implementation restrictions. Since only few variables can be placed in the register, it is important to carefully select the variables for this purpose. However, C will automatically convert register variables into non-register variables once the limit is reached. Don't try to declare a global variable as register because the register will be occupied during the lifetime of the program.